So this is the fourth in a series of videos on binomial distributions. And when we closed the last video, I asked you to calculate a problem where you rolled 5 dice and you were trying to figure out the probability that you would roll 2 6s with 5 dice. And this is the problem that we got. And I asked you to work that on your calculator, so let's see if we did this. And I'll do this partially with a calculator and partially by hand. So 5 choose 2 is 5 factorial over 3 factorial, 2 factorial. And I think I can simplify that in my head. Let's see, that's 5 factorial over 3 factorial becomes 5 times 4, and then 2 times 1. So that's 20 over 2, or 10. Then you have 1 6 squared. I think I can do that in my head. That's just 1 over 36. Let's pull that down. Now 5 over 6 cubed. 5 cubed is 125. 6 times 6 times 6, I'm not sure what that is. I'll do that on my calculator. That's 6 times 6 times 6 is 216. And I might be able to simplify that in my head, but I don't think so. So I'm just going to do this in my head, right? I go 5 choose 2, which I can calculate as 10. 1 6 squared, which is 1 squared over 6 squared, 136. And then 5 6 cubed is 5 cubed times 6 cubed, right? Just think what that is. That's 5 to the third and 6 to the third. And that I did on a calculator, and I got 125 over 16. So now what I'm going to do is I'm going to calculate this out with a calculator. Just give me just a second. If I did that right, I get about 16.1%, or in decimals, 0.16075 is actually what I get. So that's the probability that if I roll 5 dice, I will get exactly 2 6s. Let's go ahead and look at another problem. And let's look at, this is often used for a shipment. So let's say, for example, you went into the t-shirt business and you took a shipment of 400 t-shirts. And the problem was, let's say they were printed t-shirts with some kind of funny saying on them. And the problem is that 2% of the t-shirts were defective. Now the key here is that you have a fixed, let's see if this is binomial or not. You have a fixed number of trials, and the probability of each trial is constant and independent of each other. That may not be true always, but we're going to assume it's true in this case, so that it fits our model. And what you want to know is the probability that X, that is X is the number of defective t-shirts you have, is going to equal to 4. A more realistic problem is you might want to find out the probability that you have defective either 1, 2, 3, 4, or 0 defective t-shirts, but that would just be a problem where you would add them together. So then what you do is you just plug in the formula, right? The formula, let's write the formula over here. It's N choose K, and then it's P to the K, 1 minus P to the N minus K. Now, there's something strange here. P here is defined as success, but we're going to define success as having a defective t-shirt. That's because success doesn't mean good or bad here. It just means how you're going to define yes and no. And it doesn't matter if you defined it. If you defined it a different way, that would be fine. So let's see if we can do this. N here is the total number of trials, so that's 400. And K there is the number hypothesized that are success, in this case defective t-shirts, so that's 400 choose 4. And then P would be 0.02. That's the percent of being defective. And K is, again, the hypothesized value, so that's 4. And then it's 0.98, right, because that's 1 minus p. And n minus k would be 400 minus 4, so that's 396. And now it's just a matter of plugging in your calculator. So make sure that you understand how the formula and how everything fits. N is the number of trials, 400. K is the number of successes. Success here is defined as having a defective t-shirt, so that's 4. P is the probability of success, that's 2%. K again is 4, that's what we said before. Now 1 minus P, if P is 2%, then 1 minus P would be 98%. And N minus K would be 400 minus 4, so it's 396. So now it's just a matter of plugging the calculator. So you have 400, choose 4. Sometimes, even though I can plug in this calculator, sometimes I like doing this in kind of partially in my head just so I make sure. This is 400 over 396 times 4. The 396 and 4 cancel. That's 400 times 399 times 398 times 397 over 4 times 3 times 2 times 1. Let me go ahead and do that. 400 times 399 times 398 times 397. I should get a huge number. An enormous number, in fact. And then I'm going to multiply that by 0.02 raised to the 4th. Make sure you do 0.02, not 0.2. And then you're going to multiply that by 0.98. And it looks like I made a mistake. I got a number greater than 1, so I'm going to try that all over again. 0.02 raised to the 4th times 0.98 raised to the 396. And I get approximately, let me go and write this down, and get approximately 0.056 or 5.6%. And usually you want to calculate this twice just to make sure you don't make a mistake on the math. So let's think about what we want to do here. What we want to do here is we want to recognize binomial situations. You want to be able to identify N, K, and P, and you want to apply the formula, the binomial probability formula.